Hello everyone, this is Dr. Webb. In this video we're going to be looking specifically at limits as x gets really big, so as x goes off to infinity. So let's just jump right into it. This is a fact that I'm sure you're not too uncomfortable with, that if we look at what happens to a power of x as x goes off to infinity, well, it depends on what the power is. And so if the power is positive, then the function is going to be going off to infinity. So if you think about what happens as x squared, as x gets really big, well, if you take a really big number and square it, multiply it to itself, it's going to get huge, right? And so x squared as x gets really big as well. And that's going to be true for any positive power of x. Now, on the other hand, if we set n to be 0, well, x to the 0 is just equal to 1 for all x. And so, in that case, when we're thinking about the limit, we're just taking the limit of a constant function 1, and 1's not changing at all, so that limit is going to be 1. Now, last but not least, if our exponent is negative, then the function x to the n is going to be going off to 0, because if you're doing something like the limit as x goes to infinity of 1 over x squared, so here our power is -2, so this is talking about n equaling -2. Well, as x gets really big, x squared is getting really big, but then you're going to have 1 divided by something really big and positive. So what happens when you have 1 divided by something really big and positive? This is going to be very close to 0. And as x gets bigger, x squared is going to get even bigger, and so then we're dividing by an even bigger number, and that's going to make us even closer to 0. And so this limit's going to be equal to 0. Okay, so let's apply this here. Right, so we're taking the limit of this rational function, 2x squared minus 5x plus 8, and then dividing the whole thing by x squared. Okay. Well, so on the top, the nice thing on the bottom is we only have a single x squared. On the top, we have a sum, and so we can break this sum up. So we can think about this as being the limit as x goes to infinity of 2x squared over x squared minus 5x over x squared plus 8 over x squared. Now we can cancel off x's for each of these. So we have x squared on top and x squared on the bottom on the first term. And so those cancel off. I have 5x over x squared on the bottom. So 1 power of x goes away on the top and bottom. So I'm left with 5 over x. And then plus 8x squared, there's nothing to cancel there. So we can think about this as being the limit as x goes to infinity of 2 minus 5 over x plus 8 over x squared. Okay, now let's think about what happens as x gets really big. So as x gets really big, 2 is going to stay the same. There's no x's there anymore. 5 over x, that's going to be 5 divided by a really big number. So this is going to be really small. And if you have 8 divided by x squared, so that's going to be 8 divided by a really big number. That's also going to be really small. And so what's really playing a part in this limit, what's really contributing here is just this 2. And so we'll say this limit is 2, right? And really what we're really thinking about here is we're taking the limit, we're breaking this limit up as taking the limit of 2 minus, I can pull the 5 out, taking the limit as x goes to infinity of 1 over x, and then pull the 8 out, taking the limit as x goes to infinity of 1 over x squared. Well, the limit of 2 is 2. The limit of 1 over x as x goes to infinity, that's x to a negative power. It's really x to a negative power, so that's 0. And this is really x to the minus 2. So that's equal to 0. And so what we really have is 2 minus 0 minus 0, minus 0 plus 0, which is just 2. Okay. What if we were to flip this over? Well, if the reciprocal is getting really close to 2, then if we take the reciprocal, where should the reciprocal be going to? Well, since this goes to 2, we can think about this as being 1 over that limit. And we know that limit is 2 now, so this limit should be 1/2. Okay, and this sort of leads us to a common trick that we use when doing these limits of rational functions as x goes off to infinity. And the common trick is that whatever the term with the highest power of x is on the top and the bottom, focus on those and ignore the rest. So ignore these. And the thinking here, the reason why this works, is that if x gets really, really, really big, like a googol, then if I was to square a googol, that would be enormous, 1 followed by 200 zeros. Whereas the minus 5x, that's only going to be 5 times a googol. So 5 times a googol, it's big, 5 with 100 zeros going behind it, but that's nothing compared to 2 with 200 zeros coming after it. So the 2x squared is dwarfing the 5x, and the 8 is always just staying like 8. So as x gets bigger and bigger and bigger, whatever the highest power of x is, that's going to dominate the rest of the numerator or denominator. So this 2x squared dominates the other terms. And so we can just focus on it. The bottom only has the term x squared. And so then we can think about this as ignoring these out, and it becomes a limit as x goes to infinity of 2x squared over x squared. And now we can cancel these x's off and get back just with 2. Right? When we're doing the reciprocal, it's the same thing, but now their roles have switched. X squared is the only thing I have on top. 2x squared is the dominant term on the bottom. These are getting dwarfed when x is big. The bottom, when x is really big, it's essentially going to be 2x squared. The minus 5x plus 8 is just going to be like an error that's getting smaller and smaller as x gets bigger and bigger. Okay. Now, what's a graph of this look like? So here's a graph of the function. And so we said the limit is 2. And as you see, we start off, the function kind of is wiggling around. In fact, it actually goes off to infinity as x goes to 0 from the right. This is the wrong function here. This should be flipped. take the reciprocal there. And so as x gets bigger and bigger and bigger, the function's getting closer and closer and closer to 2. And same thing, this also should be the reciprocal. So flip those two. And if we expand out in the x direction, what happens as we go further and further out? The function's still getting closer and closer to 2. And so this dashed line at 2, this is what's called a horizontal asymptote. And so you get this when you have a function whose limit as x goes off to infinity goes to L. That means this is going to have a horizontal asymptote at y equals L. Okay, so now let's look at this rational function. So we have the limit as x goes to infinity of 10x cubed plus 25,000x divided by 3x to the fourth minus 800. Right? So even though 25,000 is pretty big, especially compared to 10, as x gets really, really big, still the 10x cubed is going to dwarf off the 25,000x. So this is still the dominant term. The coefficients don't matter. The coefficients are just constants. It's the power of x which is really controlling what's the biggest. And so 10 to the x cubed dominates. The 25,000x, eventually this is going to be dwarfed. Right? If you put x equals 10 to the 100, well, 10 times 10 to the 100 cubed would be a 1 followed by 301 zeros. 25,000 times 10 to the 10, that would be 25 followed by 103 zeros. So the 300 zeros is immensely more big, immensely larger than the 25,000 times 10 to the 100. Same thing on the bottom, the 3x to the fourth, this is going to dominate. The minus 800, that gets dwarfed. So if we want to think about this limit, limit as x goes to infinity of this, it's going to be equal to just 10 over x cubed over 3 over x to the fourth. And now we can simplify. Now, since these are just powers of x, we can simplify this out. So the x cubed is going to go away. Canceling off the x cubed is going to leave me with just x on the bottom. And so this is going to equal to 10 thirds limit as x goes to infinity of 1 over x. Well, this is x to a negative power. And so we're going to be left with 0. And so, again, to think about this, as x gets really, really big, so again, think about this like x is equal to 10 to the 100. The top is going to be 10 times 10 to the 300, but the bottom is going to be just about 3 times 10 to the 400. And so when you do 3 times 10 to the 100 divided by, or 10 times 10 to the 100 divided by 3 times to the 300, let's make that clearer, divided by 3 times 10 to the 400, well, this is going to be 10 thirds, but then you still have 10 to the 100 on the bottom. So it's 10 divided by 3 Google, which is going to be teeny tiny. Very, very close to 0. Very close to 0. Okay. Okay, last but not least, for this video, now we have almost a rational function, except we have this cosine going on in there. And so this cosine is causing a bit of trouble because it's wavering around. right? Well, how are we going to take care of this wavering? Well, we're going to use the squeeze theorem. And so we're going to go back to cosine x. It's always no bigger than 1, no smaller than minus 1. And so then that means that minus 5x cosine x, so this really is like multiplying both sides by the absolute value of 5x. So this is always going to be smaller than 5x and always bigger than minus 5x. And so then when we fit it into the whole function, get rid of that straight line. Well, I have 2x to the fifth plus 12x cubed minus 5x over 3x to the fifth plus 10x squared is less than or equal to the function that I want. Minus 5x cosine x over 3x to the fifth plus 10x squared. And this is less than or equal to 2x to the fifth plus 12x cubed plus 5x over 3x to the fifth plus 10x squared. Okay, and again, we're thinking about x here as being positive because we're taking x going off to infinity. So I don't have to worry about the sign as I'm multiplying x to both sides, because I'm really thinking about what's happening is x is a really big positive number. So I can treat x as a positive number. Okay, so now we have true rational functions on both the left and the right of this inequality. And for both of these, as x gets really big, we can just focus in on the dominant terms on both sides. And so the limit, this limit here is going to equal the limit as x goes to infinity of 2x to the fifth over 3x to the fifth. The x to the fifths cancel off, and we get 2/3. This limit over here, the exact same thing is going to happen. 2/3 x to the fifth over x to the fifth. The x to the fifths cancel, and we get 2/3. So we can apply the squeeze theorem for these limits as x goes to infinity, same as we could do for other limits. And so the left goes to 2/3, the right goes to 2/3, and so that means that the middle goes to 2/3 as well. And so our answer is 2/3. I hope you enjoyed this video. I will see you again soon.